muted. Yo, what's up, guys? So we're gonna mess around with the simplex method in Python. Yeah, the code is kind of hard to see. Yeah, that's fair. Oh, right now it's something else up. Sorry. I apologize for any of that. Um, uh, okay, bro, this won't. It's just being really weird. Okay, you know what, guys? You guys can just see my whole screen. Fine. Uh, oops. Boom. Yeah. Anyway, what we're doing is we're just doing the simplex method. Let me just switch my. 1 second. Dude, this would be so elegant if we could just show this. Okay, so let's just change this to this. Show that. No. Dude, I don't know. I don't know why you guys can't see it. Yo, I fixed it. How did I fix that problem? I don't know. But I fixed it. Alright, cool. Okay, so let's start the stream now, finally. I got this working. Um so let's mess around with the simplex method. 1 second. Yeah, let's mess around with the simplex method. Let me just make sure to change my thing to the correct. I believe, yeah, I have it in here. Let's go. Save these, save everything. Alright. So simplex method, basically, so let's go back to this and let's pull up okay, cool. Simplex method is basically a technique for maximizing linear expressions subject to linear constraints. Makes sense. So like, x plus y is less than 10. That would be a good example. Okay, so that makes sense. So it's just algebra that's implemented using array manipulations. So let's say you're trying to maximize this, right? You create some variables that slack variables. Like, for example, you make it so you basically say, instead of this, you say x5 is equal to this, and you just say x5 is less than or equal to 0. I mean, greater than or equal to 0, because x5 has to be equal to that. Okay, makes sense. That's pretty easily codable in Python. So let's evaluate the objective quantity. So we just set a basic guess. So this is sort of a looping process that we're going to do. So basic variables, we just loop and then we check if the condition's done. And if not, we keep looping. So the basic variables are x1, x2, and x3 because they appear in the quantity we're trying to maximize. And also in the expressions for the non-basic variables x4, x4, x5. So we set them equal to 0. We find the thing 0. That's a pretty bad guess. So we look at the slope at all of these. We find this is the greatest slope. And then we trade this. That basis the strictest constraint on 2. Well, you just look at these and you divide it by the x2. So you get 6, 7, and 1. 14. Uh, 14. Whoa, what? Oh, yeah. Wait, what? Oh, sorry, x2. Oops, my bad. Yeah, so 28 over 2, 14. And then 6. And then, so anyways, so 0 is less than 30, minus 2x1, minus 5x squared, whatever. Yeah, so we trade 6 for 2. We substitute for 2, and yeah, we do some nice manipulation. Okay, so should we do this using matrices, or should we do this from scratch? Yeah, I sort of understand how it works, but uh, let's figure out how to code it. Okay. An array. To try and maximize this, we keep this expression as maybe its own array, like 1 to 2 to 1, and then we keep another one saying x1, x2, x3. And then we have to maximize this. Okay, this makes a lot of sense. This seems like a really logical way to go about doing it. That will be 3 times 2 since there's 3 expressions. Find the row that places, we just divide the constant column by the x2 column. Uh, the bottom row places the strictest constraint. To execute the trade, we perform elementary row operations using the bottom row to kill off the rest of the x2 column. Oh wait, don't we already have, we've already implemented a method to do this for us. It's like, what is it called? It's called, first of all, oh, this is pretty simple. So basically you just need to, we did this in our, okay, so you need to, this is in our, normalized row, and then you subtract rows. Yeah, but you need to put it in the factor. Um, Factor needs to be an int, obviously, right? It wouldn't make sense if it was anything but an int. So the max is 12. Okay, so, right? So the input should be the first array I write down. So it should be basically this array. So what is this going to be? So this array, um, okay, so it's going to be, let's say, let's call this, so let's call this vars, right? And then let's call this, Um, Yo, what is up with my keyboard? Dude, I know I typed only one, and it's like typing two. What? Why is it doing this? I only want one. Let me just Google this really quickly. Okay, you know what? It's fine. We'll deal with it. Maybe if you single quotes, doesn't for single quotes. Okay. And let's just zoom out a little bit. This is like a little bit there. Okay. Okay. So. Okay. Okay. Um. So this is going to be the array that we're actually going to put in, right? So there's going to be a constant column. So there's going to be like tab there. That way we have 1, 2, 1, 0, 0. 1, 2, 3, 4, 5, 6, 7. Okay. Why'd I draw an extra? Okay. Uh. Bro, I keep. Bro, what is with me today? I'm just like spazzing out every 5 seconds, bro. Okay. Let's go to here. Okay, fine. And we'll center them all like this. At least look decent. And then what is this doing all the way here? Okay, and then move this over. Okay. Okay, it's fine. Then finally we have the constraint on the constant on the other hand, which is for now 0 here. 2, 1. You know what? I'm honestly kind of too lazy to type this. Uh, so let's just okay, there, boom. I just had GPT type it up for me. Yeah. So much more convenient. Okay, so let's add a def simplex method. So it takes in the array as input. Um, okay, cool. So we know that the top column is constraint. So we immediately know that constraint row is equal to 0, and then Oh, sorry, constraint call, max call, sorry, maximizing row. Know that maximizing row is going to be equal to 0 all the time, but the constraint columns are going to be they're going to be I for I in range, and basically we're going to take from 1 to len, and then what we're going to do is we're going to do len array. So this is going to get like 1, 2, 3 to 4. This is going to get all the columns that are constraint rows. Let's just do. Okay, we're good. What is it again? It's Shift Alt F. Wait, like if I do like for I do Shift Alt F. I don't even know, bro. Okay, so anyway, we found the constraint rows, and it should also give us the. So we know the constant call. So if it let's have them. So it says the input should be the first array, and that's it, right? So we know that. Okay, so that's not too complicated. Now let's figure out how to do the array manipulation. So now let's just say that matrix array equals matrix of array. This is a list of lists, so boom. So the first step is to find so while not found s. And then let's set found is equal to false. And then oops. Is that actually the way it wants to format it? Okay, fine. That's fine with me. Okay, so now first what we do is we find the do we have a way we already implemented this? This is iterating over rows. We need like is pivot but for is max, but okay, we'll just do it the old fashioned way, I think. Yeah, we'll just do it the old fashioned way, which is we'll basically just find matrix.matrix and we'll just solve for it. So for I in enumerate and enumerating basically you guys know what enumerating does. Explain it. And what are we doing here? We're doing like matrix.matrix, matrix array dot matrix, and this is maximizing row. So in the maximizing row, we want to find so. Oh wait, I can do this. Okay, I forgot we could even do this one. Okay, but for I in enumerate maximizing row, if I is greater than largest grad, uh, we only really need the largest gradient, don't we? Because oh, we need the largest column. So we need the largest. Uh, okay, so if I is greater than largest grad, you basically say largest grad is equal to I. Uh, ooh, ooh. So it should be for I comma, this is the actual thing, but also it should be the grad, right? So if grad is larger than the largest grad, the gradient is larger than largest grad, then the largest grad is going to be equal to the gradient. And then largest column, that's going to be equal to I. Okay, so why is that really important that we have the largest column? I'll tell you later. Uh, we'll just keep it as a little bit of a surprise for now. Well, you guys can already figure it out since we read this, but whatever. Sometimes I can't tell if like I'm implementing along with you guys or like you guys are just watching me implement it, so like surprise. But I'm trying to make it like kind of educational, but not really. Not really just me chilling, bro. Okay, so we can tell that x2 is the largest slope, right? So we can tell that's the largest slope, and then when you divide the constant column by the x2 column. So now we need the so um I think so we have the largest column, right? So now we just need to find the values below. Um, this is one way to do it, but this is like really inefficient. One way I can think of I can do it is you could do so far we haven't done any changes to matrix, so we can do matrix dot calls. Oh wait, not matrix, matrix array dot calls or just go. We're iterating through each element. For I comma val in the reason we need I is yeah, okay, so I comma val in enumerate, right? Least val goes in. Okay, so yeah, this can change. So this will actually might change. Let's just make sure that everything makes sense. That won't change. So this works. Okay. So we could actually just get this once here. We don't need to keep finding in the loop. That's unnecessary. So we can just go boom, bam, bam, bop. Okay, constant column, right? If constant column dot I divided by val is less than least val, least val. Oh, we should actually be debugging this as we do it. Yeah. Okay, so let's just comment this out. So let's just add a return largest val. Just to make sure this is working today, so let's return it. So let's just do a quick print, just to okay, two, and then largest column. Let's just make sure that's correct. It should be returning oh, after I remove the print. Sorry. Okay, so if least val is then least val is gonna equal um val. And we need to keep track of this I. So we need to keep track of these I's are really important, bro. This is a little bit at least okay. So now let's just add a quick return release row. I should just keep this print simplex array so I can do it as I do it. Hmm. Yeah, that would have been a bug. I completely forgot about that. It's a bug. We fixed it now, though. Should work now. Let's just have it print out the. So if ratio is less than least one. The ratio is being computed properly, clearly. There's some problem here, I assume. So let's print. Oh, wait, what? Oh, it should be least ratio. Ooh, okay, yeah. And then have a separate tracker for the least cost. Or I can just say it's none because we have least ratio doing the hard part. And because we don't really care about the least ratio, it's just a. Then we just have to say least ratio. Oh, shit. Okay, cool. 3. 0, 1, 2, 3. Okay, it's working properly. So we're here now. So we have the column that we need to eliminate. That's going to be the least row. Right. Just make sure one more time, just that it works. Okay, cool. So we know that this is the row. We have the column and row that we have, right? We have the one that places the strictest constraint. So we just kill off the rest of the x column. How do we do that? Well, we can take a little bit of look at our not here our REF code. So we just do. So first we have to basically what we have to do is we have to do matrix array dot normalize row, and we need a pivot index. Uh, wait, what? So let's check our code. Let's check our code here. Yeah, pivot index. Uh, and we just We want it for all the rows, right? Or we start with this row and then we multiply by the factor. Okay, yeah. So what row do we want it for? We want it for the least row. Uh, um, and let's actually write a nice little nice little in our nice little easy functions here in our show transpose in show. Right after show, we need to write def to array self self dot matrix. So this way we won't ever have to access self dot matrix like to get the final value. And we normalize the row, and then we need to basically just wait. We can just copy that code literally like bar for bar. And uh and the current column is gonna be or just call or just call row index is going to be equal to basically the row index is going to be the least row. And instead of row index, we're going to do least row. And quickly, we're going to do return matrix to array. Matrix array. Oh, yeah, okay. So we need the least row, and then we need the oh, oops. -1. For now, for debugging purposes, let's just keep it like this because the printing is so much nicer when I do show. Now show should work here. I believe. Yeah. Yeah, wonderful. And this is just basically our value. All right. It doesn't say anything about like uh. So basically, the max value. Max value. Well, sorry. Row zero. Oh, maximizing row, maximizing column. But maximizing row, right? And it's gonna be the constant column. Or yeah, sorry. I'm just gonna do uh debug right? Telemetry, iteration I, okay. Um, Oh, neat. Matrix stuff. Maximizing right. Dude, I really want to know. So, okay, if all, I can do if all, matrix array, all matrix, maximizing row, x is less than 0 for x in, it's found. So found equals none. And so max value. So so let's say try except block for the button process for them. So let's do try. And then we do accept so we have to do matrix array dot show. Oh, let's also print the nice debugger at least. Oh, so this is gonna be the at least it's gonna be boost row. What? Oh, okay, yeah. So we'll just grad. Fine. And then it's the least. Yeah, the largest grad's going to be 0. Wait, what? They should have triggered the. Wait. What? They should have triggered the thing. Why does this not work? Oh, that was very smart. Never remove the debugging information that easily. Oh my, bro. Bro, always me. Oh, wow. Okay. Yeah. Okay. Bro, I'm like honestly kind of tired, bro. Thanks for watching, guys, though. I hope you guys learned something about the Simplex method. I go through it kind of fast, though. Okay, cool. GG, boys. Yeah, this code works. And we've debugged it like reasonably. I'm really happy with how we debugged this. We went through it step by step, step through the code, realized the problem, looked for a solution, eventually realized it was a very trivial solution. We just got to break out of the loop. We should have just returned the max val there, but yeah, break out of the loop works just as well. So cool. Yep, we've done this, and now we're here. Linear polynomial.